Problem sheet 6, question 6. Consider the transportation problem below, with demand nodes A, B and C and supply nodes X, Y and Z. First use the minimum cost method to find a basic assignment, and then use the stepping stone algorithm to show that this is the optimal assignment. Which demand nodes are left unsatisfied? So the first thing to notice about this question is that the sum of the demand is 55, but the sum of the supply is only 35. Therefore, we don't have enough supply to meet the demand. So we have unequal supply and demand. So in this case, we'll have to introduce a dummy supplier that will supply any unmet demand. So to do that, we'll have to redraw this table with a dummy supplier and the same 3 demand nodes. And we have 20 units of unmet demand, so that means the dummy supplier will supply 20 units of unmet demand. The root costs are going to be the same for all the non-dummy nodes. However, for the dummy node, there is no cost at all for not supplying unmet demand. However, it is undesirable, but it makes no difference at the moment in this formulation which demand node is unmet. Now on this, we will find a basic initial solution using the minimum cost method. When we have unmet supply and demand and we're introducing a dummy node, we ignore that dummy column when we think about our minimum cost method, because we should be thinking about the real cost rather than the dummy costs. So what is the root with the minimum cost that is not associated with the dummy node? That would be AZ. So we can fill that with as much as possible, and that satisfies the Z column. After that, we will fill up CY as much as possible, and that will satisfy the C row. After that, we'll fill up AX as much as possible, and that will satisfy the X column. Then we'll fill up BY as much as possible, and that will satisfy our Y column. And now we have filled in all the non-dummy cells, so now we need to consider which dummy cells we need to fill up. Doesn't matter which way around we do this, they all cost the same. So AD, we will fill that up as much as possible. And then BD, we will fill up as much as possible. And we do not need to fill up CD. So this allocation corresponds to demand node C being completely satisfied, but demand nodes A and B both being unsatisfied by 10 units each. The question then asks, use the stepping stone algorithm to show that this is an optimal solution. So let's begin the stepping stone algorithm. We will consider every non-basic root. So first we will consider AY. The loop here is this, given a net unit cost of 1. BX, the loop here is this, given a net unit cost of 6. BZ, the loop now is this, with a net unit cost of 1. CX, the loop now is this, given a net unit cost of 15. CZ, the loop now is this, given a net unit cost of 8. And finally we can consider CD. The loop now is this, given a net unit cost of 5. And so the cost of changing any of the non-basic variables basic is positive each time, and so we cannot make any more improvements to this allocation, and this is the optimal assignment. The demand nodes that are left unsatisfied are A and B.